Now, of course, things can also go wrong when sending a request. For example, there might be no internet connection. It temporarily went away. That's one possibility. But there also might be something wrong with our backend, and an error might occur on that backend. And to simulate that, I will actually return a different response here after this delay. Temporarily. I'll get rid of it later, but for now I want to return a response that sets a status code of 500. And that's how you can do this in Node and Express. This creates a response with a status code of 500, and I'll call the JSON method on that to then really finalize that response, so to say. So now this route will no longer return the places, but instead this error response. And of course, nobody would do that, but for simulating the error use case, this is perfect. You now just have to go back to that terminal where you started your backend development server and quit it by pressing Ctrl+C and restart it so that those code changes are picked up. With that, if you now reload, you'll see that we're fetching those places and then they never arrive. And we see an error here in the developer tools that we got some HTTP related error. Well, how can we now handle that in our component? Well, for example, again, by adding an extra signal. An error signal, for example, though the name, of course, is up to you. And that could store a string value, so the error message. And initially that could be an empty string, since initially we don't have any error. But then I wanna set this signal to the error message if an error occurs here. And for that we can add that third and last function to our observer object, the error function, which will be triggered whenever some error is thrown somewhere in that observable chain. And Angular will produce an error if something goes wrong technically. So if we have no internet connection, for example, or if we get an error response. In both cases, Angular will produce an error value and this function will get triggered. And it will receive that error information then. So in here, we could then use our error signal and set it to that error we're getting here. It's worth noting that TypeScript doesn't know what type of value we'll get here though. Nonetheless, we can try setting it like this. And then we can of course go back to the available places template and add another check here. And also update this first check. Because now here we can check if we're fetching and error is falsy. So this error signal produces a falsy value. In that case, I want to show this loading text. But otherwise, if we're not fetching or we have an error, I don't want to show that. And instead, we can add another if check here and check if error produces a truthy value. So if the error signal has a non-empty string. And in that case, I want to output a paragraph with the class fallback-text on it that will output that error message. So we can use string interpolation to output the value stored in the error signal. And if you save that all and you reload, you'll see that after a while you get this object thing here. And we're getting this because this error we're getting here in this error function, this argument here, is actually not an error message. Instead, it's an error object, which, however, should contain a message property. So we can try accessing it like this. And with that, if we reload, we can again try fetching those places, and after a while, we get some message. However, not really a user-friendly message. So what we might want to do instead is maybe log that error for ourselves, but show a more user-friendly message here. And we could, of course, do that by simply console logging the error here. Or alternatively, we could try sending it to some analytics server if we had any. Here, I'll just log it. And then maybe output some hard-coded message like something went wrong fetching the available places. Please try again later. That is something we could do here. And if we save that and we reload, we should see that more user-friendly message here. And we still log that error object here, which now contains more details about the error. But again, we could also use an operator here, not because we have to, but because we can, to keep these observer functions leaner. And therefore, we can add a second argument to this pipe method. And after adding this map operator, we can add the catch error operator, which is another operator that's imported from RxJS. And catch error does what its name implies. It, in the end, is responsible for handling errors and for potentially transforming errors. For that, it takes a function, just like map, and that function takes an argument, a parameter, which in the end is that error that we got. It actually also takes a second argument, which is that observable that emitted that error. So this observable that's created by get. But here I only care about the error. And then catch error actually needs to return a new observable. So unlike map, it should now not return some data to which this error has been converted, but instead it must return a new observable. And I'll generate a new observable here by calling throw error, which is another function that must be imported from RxJS as well. But throw error is now not an operator that you would add to pipe, but instead, like interval before, it's an operator, a function that generates a new observable. But it will generate an observable which will automatically throw an error again, which is a behavior I want here so that this error function of the observer gets triggered. But now we can configure that error that will be thrown here. And for that we need to pass another function to throw error. So lots of nested functions here, I know. But this function now should return an error object, or anything which you want to throw as an error. But here I'll generate a new error object using the built-in error class, the built-in error constructor that's built into JavaScript. And here you can pass an error message to this so that you generate an error object which has this message which you pass to the constructor attached to it. And I'll grab my message from down here and use that here as a value for that error constructor. And that's now how we can transform this error. We can now still log that original error here if we want to. For that, we just need curly braces now, since I now have multi-line code and not just one statement, not just one expression here. And we need to return the thrown error. But with that, we transformed the error and logged it. And down here in that error observer function, we can now log error.message as before. We can also add a type annotation here and make it clear that this will be of type error, so that it will be such an error object. And since those objects have message properties, we can safely access message here. And again, just as with map, you don't need this operator. It does make things more complex here, but you will see it in some Angular projects. It can be useful for getting your error transformation logic out of the observer functions, which you typically should try to keep clean and lean. And therefore I wanted to cover it here as well. With all that done, the behavior should be the same as before. we see the loading fallback, and then after a while, we see that human-friendly error message, and we log the error object to the console. And with that all done, I'll get rid of that error in the backend code and comment out this line, since I of course only wanted to show this error handling for demo purposes. So with that commented out, we should restart that backend server so that the updated code is picked up. And with that, if you now reload, you should see that the places are fetched and displayed successfully again. And that's how you can handle error and loading states in Angular when working with HTTP requests.